Hello.
Hello.
Okay, so welcome everyone to this tutorial of week 5. This is Rahuldev Ghorai from ICT. Uh, we will, yeah, so today's, this week's topics mainly integration theory of Riemann into sense of Darbox. And then some integration rule, fundamental theory of calculus, and the last topic, as uh, Sir has told that last topic, I mean this one, the cruise will in stock integral. Sorry, this is not working. Wait a minute. So I mean last topic means the cruise will in stock integral. I'm mainly talking about. So that we will not do the problems on those. So as he told, we will not do any problem on that. Otherwise, we will have other 4 topics, mainly integration, very much. So, if you have any doubt, you can ask from here. Otherwise, we will move to solve few questions. So, hopefully, you know like upper sum, lower sum, all these things, and how to what is the integration. So in the sense of limit. So limit of that sequence, right? Integration, you can think like that. Summons, and how do you show one? Let's say like you have functions like fx, which is 1 and 0. If x is equal to 0, x not equal to 0, whether it is integrable or not. How do you show? It's precisely using Riemann function or the Dirichlet function, whether it is which is not integrable. Uh, like x belongs to Q otherwise. So precisely how to show that this is a integrable, okay, to use the definition of Riemann integration, right? Whether they are Riemann integrable in the sense of Darbox, right? And many there are many interesting questions which we will be solving today on this Riemann integration. Right. So mainly you have this. If you have a function fx, is whether what is the meaning of this fx? One can think of limit, right? And limit over this. Sometimes this is norm of Pn tends to 0, right? Then tends to infinity. E of Pnf, or also if it is integrable, this limit will be there equal tends to 0 L of Pnf. Hopefully you know what is this Pn norm, that is maximum over this I. You have this Pn, let's say have n number of points where a0 is equal to a, and a1 up to you have an which is equal to b, and this is over I, which is belongs to 0 to n. 0 to n, you have this xi minus 1, sorry, xi minus xi plus 1 minus xi, maximum of that is Pn. As n tends to infinity, you will see that we will take more and more points, and that you can think as a limit also, limit, right? And what are this UPF? If you have a UPF, that will be some mi, sorry, summation I equal to 0 to n. This is capital Mi, right? That's how he described, and xi plus 1 minus xi, where Mi is the supremum over that x belongs to xi plus 1, xi to xi plus 1, of course, xi to xi plus 1, uh, fx, right? And small l, so you have this LPF, which is summation I equal to 0 to n small mi xi plus 1 minus xi. As you know, the small mi is a uh, infimum that on the same interval xi to xi plus 1, right?
He used the notation of xi minus 1, and I goes from 1 to n. Does it matter?
No, it does not matter. Yeah, because this is, yeah, you can write this as uh, summation some I is equal to that. Sorry, what I minus 1, instead of I you put I minus 1, so I is equal to 1 to n. Sorry, it's a, this will be for me. This will be n minus 1 up to, yeah. Sorry, yeah. Then it will be okay.
Yes.
Yeah, so then it will be I is equal to I minus 1. Yeah, I is equal to 1 to n. This will be some mi minus 1 times x I minus x I minus 1, and this mi minus 1 you can think like, you can write this as some m tilde I, right? So even some indexing, there's nothing, that's not a problem. So yeah, otherwise this is the idea. I mean, this is the, these are the upper sum and lower sum, something, right? And so knowing all these things, we can solve some few problems on this integration, like Riemann integration. Okay, so I'll start with few questions, some questions maybe. Then we'll see like how many things, how much we can cover here. Okay, so first question will be question one. You have a let's say function which is from a b to real number, which is uh, at least it has to be bounded. It means then only you can think about Riemann integration, right? Okay, so first will be little not strange, but yeah, evaluate the limit limit n tends to infinity 1 over n plus 1, 1 over n plus, sorry, plus 1 over n plus 2, plus 2 1 over n plus n as an integral. Hopefully it's visible, and will you try? So, I mean, do you want to try or shall I just do
Yes.
it? Okay. I'll wait for maybe not for 2 minutes, let's say.
ln of 2.
This will be ln of 2. Oh, wait,
Yes.
what else? Just let me check the answer. Sorry for the interruption, but yeah, I have to check the answer whether it is correct. Then I will not do maybe. It should be not true, but I just confirm it. Okay, so how you did that?
I wrote it as a sum.
Okay.
Summation r goes from 1 to n, 1 over n plus r.
Summation, you can write this as yes. Summation r equal to 1 to n,
1 over n plus r.
1 over n plus r. True, yes.
Then I took n outside.
Yes, so that will be summation r equal to 1 to n, 1 over n will be outside, 1 over 1 plus r over n, right?
Yes. This is integral 0 to 1, 1 over 1 plus x dx.
This is
Integral 0 to 1, 1 over 1 plus x dx.
1 plus x dx, because if you take like that partitions are like uh, you start with 0, then 1 by n, 2 by n, like that you have n by n, that is a partition, right? For any, this is a
Yes.
partition Pn whose norm is 1 by n, so it converts to 0. So that's why this one will converse to this one, and which will be the, I mean, as a limit n tends to infinity, of course, right? It's not equal. So if you take limit as n tends to infinity, right? Limit equal to as limit n tends to,
Yes.
so then it will be this, and that's what we want, and that is nothing but ln 2, right? Ln of 1 plus x, yeah, ln 2. Yeah, this will be the answer. Still, I'm not getting the answer. Yeah, yeah, ln 2. Yeah, it's correct. Okay, so this type of might be then. Okay, no problem. I saw a few interesting questions. Yeah, so yes. Second question. If a function is continuous on the closed interval a to b, and also fx is strictly greater than equal to 0. Okay, that is also on a to b, and integration over a to b f x dx is equal to 0, then f is identically 0. How can you prove that?
No idea.
Okay, so if you see, if f is not equal to 0, if you start with this, I will just give you hint, then you think. Let me write it in a different color. Okay, answer. So if f is not identically 0, not identically 0, if f is not identical, then what will happen? Then there
It
exists
is greater than 0.
C, yes, belongs to AB. Do you get it now? Like, can you say, do if such that FC is strictly greater than 0? Now you think. I will just give you two ways.
Yes. Then we can get a neighborhood around C
Good.
such
Yeah.
that in that neighborhood f of x is greater than 0.
Yes. Yeah, that is true.
So the integral must be positive in that neighborhood.
Exactly. So that idea is good. Idea is very good. Right? At least just true, but just correct. Okay. But can you precisely do maybe more? But like mathematically, you have to write, right? So
There exists a delta greater than 0 such
yes,
that uh,
if I get the news as
for
that.
all x in the interval c minus delta to c plus delta,
True. C,
f of x
let's
is
say,
greater than 0.
yeah. So C minus delta to C plus delta fx would be strictly greater than 0, right? Not greater than equal to 0. So FC fx greater than 0
Yes,
on this, right? I mean, let me maybe take this one that side, maybe something like that. So, I'm sorry.
yes. Can we take closed interval here?
I mean, this is yeah, open interval is better. I usually interval means I never means we mean open interval, so it might not be good thing to take here. So on this, right? That is we know that's right, and fx
Yes,
is 0 everywhere else maybe or greater than equal to 0. We cannot say that fx is
yes.
identically 0. It can get than equal to 0. So now what will be happen? A to b fx dx. What will be that? Can you write like this?
A
F
to c minus delta.
exactly c minus delta to c plus delta fx dx plus uh, c plus delta to b fx dx. What about this term, last term, that is greater than equal to 0, you know? At least greater than equal to 0, you know, right? Because fx is greater than equal to 0.
Yes,
Why? Because fx is greater than equal to 0, right? And this is also greater than equal to 0.
Yes.
Now, but this quantity, how do you show that that is strictly greater than 0? So for that, what you can say, this fx, right, is a continuous function, right? So it is uh, less than sorry, fx minus fc is less than epsilon, right? For all x minus c less than delta. Let's say for that delta we are working with, and that epsilon, for all epsilon there is a delta, right? Let's say that epsilon is nothing but fc over 2, because fc is strictly greater than 0, not over 2. Let's say fc, yeah, no, no, yeah, over 2. Why, you will understand. You understand the definition from the definition of the
No.
continuity? What is the definition of continuity? For all epsilon there exists a delta.
Yes.
Yeah, so that epsilon I'm taking fc over 2 because c is a constant, right? You can take fc over 2 because fc is strictly greater than 0. That we know, because c belongs, that is given, of course, that is given, and not given, there exists that c, right? So fc over 2 itself, if you take fc over 2, why, that you will understand it. But fc over 2 you can take, right, epsilon.
Yes.
And for that delta, let's say we are working with, so that I did later. So for that, let's say for that delta also you will have, even if it's not, then you take minimum of that 2 delta. Okay, so let us may start with even this one. Okay, uh, if it's continuous. Okay, so for all epsilon, this the up to it, this is okay, right? This part, all this part.
Yes.
Yeah. So now for all epsilon there is a delta. So let's say epsilon equal to fc over 2, which will be greater than 0. So for this epsilon also there will be a delta.
Yes.
So
Yes.
that, so then what will happen? Fx minus fc, what can write, less than fc over 2 for all x minus c less than some delta tilde. Do you understand this? There is a delta, right, for all epsilon.
Yes.
Now understand. Now okay. Now fx minus fc less than fc over 2 means fc less than fc over 2 greater than negative of fc over 2. Do you agree with me?
Yes.
What is this? What does this imply? Fx less than 3 fc over 2 and greater than fc over 2.
Yes.
So that implies fx is strictly greater than 0 when x minus c less than delta tilde. You got it?
Yes.
Now let's say I start with integration to a to b fx dx, and we do same business a to c minus delta tilde. Now fx, right, dx plus c minus delta tilde to c plus delta tilde fx dx plus c plus delta tilde to b fx dx. Now everything same. Now we say this is greater than equal to 0 because fx is greater than or equal to 0 means you can say that integration over that any integration that will be also greater than equal to 0, and this one also greater than equal to
Yes.
0. But we cannot stay still about this. What about this? So what you can write is greater than equal to, can we write this one, delta c plus delta tilde fx dx, because other two
Yes.
terms are positive. This is also positive, but I need to show the contradiction. So that's why now fx, in this interval c minus delta tilde to c plus delta tilde, it is greater than, strictly greater than fc
0.
over 2, right?
Yes.
C plus delta tilde, okay, you can write fc over 2 dx because f greater than than g implies integration of f greater than integration of g. So now what is your fc over 2 is constant. So integration over del, this one will be c plus delta tilde minus c plus delta tilde. That implies delta tilde times fc, which is strictly greater than 0. Because delta tilde is greater than 0, fc is greater than 0. So what you get, integration over fx dx is strictly greater than 0, which cannot happen. So that is all started because we assume that f is not identically 0, there exists a c such that fc is strictly greater than 0. So it cannot happen, no such fc can exist. So that's why the thing, right?
Yes.
Did you get it?
Yes.
So what has to happen if a positive function, you have a positive function and integration of that positive function is 0, then the function has to be 0. Of course, it has to be a continuous function, right? So if I ask you
Yes.
if I am removing continuity, then can you give me example? I mean, this will not happen if it's continuous. F cannot be, it may not be equal to 0. Still, the integration is 0. Positive function. Let's say positive function. Only the continuity is not there.
No idea.
Okay, so this is red color. Let's write maybe if f is equal to, let's say 1 0, x is equal to 0, x is not equal to 0. What about this function? F is greater than equal to 0. Integration of f dx, that will be 0. You can just do it.
Yes.
Yeah, understand, right? It will be. You have to prove it,
Yes.
but it will be 0, right? But
Yes.
but f is not identically 0, not identically 0, only because of this is not continuous, because not continuous, right? Understand? Because if it's continuous, it has to
Yes.
be 0 identical. That is very easy one example. You can construct many other examples also. Okay, so is it okay, Advait?
Yes.
Advait, so anyone else here or like otherwise? Anyone else here? Otherwise, I am only talking with you. Maybe it will be like looking like. So, if anyone else there, you can also talk. But yeah, I'll move to the second question. Okay. Okay. So whoever will be watching in the YouTube, you just pause and you think first, and then look at the answer. How I am doing. Right. First, try to do by yourself, and then do it. Then. See the way I am doing. Okay, it will be better for you. Okay, so I'll move to the next question. That is question number, I think it will be 3, right? Question number 3. Yeah, question number 3. Question number 3, which is let's say we have a function g. Let g be continuous on the closed interval a to b. Mostly we'll be doing things on closed interval, okay, integration, and gx is equal to a to x gt dt. Then gx is equal to 0. I mean g is identical to 0 for all x belongs to a to b. Please try, yeah, for some time. Then hello, hello.
Yes.
Are you doing?
Yes.
Okay, no problem.
I think I got it, but not that rigorous.
Yeah, tell, you can tell.
So maybe we can differentiate both sides.
Yeah. How do you know the function is differentiable?
Uh, Maybe by fundamental theorem of calculus.
Okay, so if this is a continuous function, then yeah, usually it happens by using that you can do it. Yeah, then g prime x will be gx. I'm just thinking, can
P
we
of
do it?
x.
Yes. Then
And if gx is not equal to 0 for the sake of contradiction,
Yes. Then
maybe we can divide by.
now then what will happen? So see, I will do maybe in a different way, but I'm just taking your whatever you are telling. G prime x will be gx. Then what will do?
Then we can maybe divide by gx.
Yes. Then it will be ln of gx integration. I took integration also x plus c, right? So gx will be a e to the power x. That's not it.
But ga is 0, right?
Yeah, I can use that then. So ga is 0. So that implies a will be 0. So gx is 0. So but without doing derivative, can we do that? I mean, this is okay also. We can just use this and let's leave it. I mean, it will be otherwise it will be very lengthy also. Let's keep it like this.
But how that a came,
Sorry,
capital A.
gx is equal to e to the power x plus c is equal to e to the power c times e to the power x. E to the power c is equal to a some constant. Is that any
Yes.
problem? Hmm? It's okay.
But a cannot be 0 because it is e to the power something. So that is the contradiction.
No, a has to be 0 because this. I mean, that's what it is telling, right? This initial data,
Yes,
initially
a has to be 0, but a cannot be 0 both at the same time. So that is the contradiction.
contradiction to the fact that gx is not equal to 0. Yes, yeah, that also. But yeah, that rough idea is okay for doing this. So I think you know at least this one. This f is continuous. Then fx. I mean this gx is equal to a to t gt dt is differentiable, right? Sorry, a to x, not t, a to x. This, if gt is continuous, g is continuous, then it will be this gx will be differentiable. Actually, this gx should not be. This is like this. So capital usually we write capital G. So then it will be easy to discuss that g is continuous imply capital G is differentiable, right? And g prime will be g. And g prime of x will be g. That this can be rigorously proved even using like very elementary calculations, using elementary results. I mean that simple differentiation and all. I mean, you start with like g of x plus h minus g of x over h, and take limit h tends to 0. You will see that is nothing but g small g of x. So it can be very easily proved also. I don't know whether he did. I think he did also this one.
Yes, I think.
Yeah. So now as a mm, yeah. So uh, f is let's say minus 1 to 1 to r, and fx is equal to 2x sine 1 over x square minus 2 over x cos 1 by x square. When x is not equal to 0, I'll just write it. X square, x is not equal to 0, 0 when x is equal to 0. Okay, so this is a function which is not integrable. How can you show say that? I mean, So what you can give, say f is unbounded on every neighborhood of 0. So I think you have seen that at least the function has to be bounded, right? For the Riemann integration. So not
Yes.
Riemann integrable. But what you can show that it has an antiderivative. It has an antiderivative. What is that? The function phi x, if you write like this, x square sine 1 by x square, x not equal to 0, and 0 x equal to 0, you can show that. I think we have done also that this function is differentiable. And what you can show that phi prime x is nothing but the fx we started with, this fx. This fx. So phi is the antiderivative of f in that time. So when this is happens, so what equal is an antiderivative of the function f on the interval minus 1 to 1. So if can have antiderivatives, so but still it is not, it may or may not be differentiable. Hmm?
Yes.
And why I said that? Do you get some more thing? Because if I take a to x fx, that does not make sense because f is not integrable, right? So,
Yes.
and if you write fx is equal to this, usually if f is integrable, then you can have this is like this. But even without having this one, we can have this type of relation. That is that's originally always from here. Fx equal to all the antiderivatives. Oh, okay. So all the antiderivatives cannot be written like this integration, right? But you have like this type of integration, then that will be antiderivative. Do you get what I'm saying? So if you have fx and your function is integrable, let's if it's integrable, then f prime x is equal to f. So capital F is the is an antiderivative of f. But all the antiderivatives, if you have for all function, antiderivatives are not like this. This is what I wanted to say here.
Yes.
Okay. So that is one thing. So wait. So let's. Can you say this about integration a to b 1 by x dx, whether integrable? Let's say if a is strictly greater than 0.
Is B greater than A?
Yeah, b also greater than a. If is b is less than a, that it will not be happen. So yeah, b less than b. Yeah.
Yes, this is integral
Why?
because 1 by x is continuous, right?
Yeah, that is true. Yeah, so that's how it is done. That is continuous. So continuous on the interval, closed interval a to b, only if a is strictly greater than 0. So continuous. So integrable. That is true. Okay. Some question I found, but I don't know how to do it. Let's write it. Maybe we'll try here. Some question. So let's say if it's continuous on R, and you have minus x to x ft dt is equal to 0 for all x belongs to R. Prove that f is an odd function.
Can you give some
Sorry?
hint?
Yeah, I'm also thinking, so that's why I can't give you it. So this is something I'm also thinking now. Let me think, then we'll give. I will give also. Huh?
Yes,
Something to maybe this minus x to 0, 0 to x, some such thing you have to do. But I am not getting exactly what to do. Yeah, like that. I mean, maybe you think like splitting this minus x to 0 and 0 to x. Hello.
Yes.
You thought something like, see, let's say capital Fx. This is answer. Like I'll try. Fx is equal to what do you know? This is 0 to x. It's fundamental theorem calculus. How you will use this Fx, right? Hmm? Okay. So what is the meaning of that? So f prime x is fx because f is continuous, right? Given, so that will happen. Hmm?
Yes.
Okay. And so what we need to show that this is fx and f of minus x mainly, huh? F of x, and you have to find the relation between fx and f of minus x. So fx uh, and let's say fx plus f of minus x. What will be that? F prime x plus f prime of minus x, right? Mainly that is nothing but ddx of fx plus f of minus x, right? Is it correct?
Yes.
So that is equal to ddx of what is fx? 0 to x ft dt plus what is f of minus x? Okay. F of minus x will be
0 to minus x.
yeah, that is how we have defined. So I was thinking, can't we do minus x to 0 dt?
Maybe then we can do some substitution to simplify.
Sorry?
Some substitution, maybe.
No, I don't know whether we can do this. F of minus x equal to f prime of minus x. That I am not. I don't know whether I am doing correct. Hmm.
But
I think that will
I
be
have
negative.
got one result. Integral of 0 to x f of t plus f of minus t dt.
Sorry, 0 to
Integral 0 to x
0 to x.
f of t plus f of minus t.
Yes,
This is 0.
this is 0. Yeah, but I cannot say anything about this because if it's not positive function given, right? Otherwise, you would have say something.
Yes, but 0 for all values of x.
That I understand. Uh, okay, so how do you get that? That is a integer, just a variable change, right? Change of variable.
Yes.
Yeah, from there, if you take integration, you will get things maybe. No, you will not get things. Okay.
I
All right.
split into minus x to 0 and 0 to x. Then I got this.
Yeah, yeah, I understand. I understand. So, what is above minus x ddx of? Actually, yes, ddx of f of minus x is not f prime of minus x, right? No, it's okay.
Right.
Yeah, right? This will be negative, right?
Yes.
Am, am not I correct?
Yes.
Then we are done, right? So negative of 0 to minus x ft dt, and that is nothing but So leave this one for now. I mean ddx of what we have, minus x to x, ftdt, right? And what is given,
Yes.
this one is 0 given, so ddx of that will be also 0, and that means function is odd. F is an odd function on this.
Yes.
Okay, so that is gone. I hope it will be okay. I'll share also this one with you guys. Question, different question. Okay, so difficult questions are, I don't know whether it's over or not. I'll just write one other question. Let's say you have, if it's continuous again, if it is continuous on a B. See when
Can
if
I
it's
take 1 minute to drink water?
sure, I'll just write the question. Okay, nothing else I'll do.
Yes, I came back.
You got it? No, no, you came back. Okay, okay, okay. Yeah, try.
No, no. Can you give some hint?
I mean, if I give it, then done, gone. I mean, kind of, yeah, no, I can give. Hint is like, try to use the result that integration of positive function is 0. My suppose non-negative function is 0 implies the function is 0. We know that result, right? That we have proved also here today.
Yes.
Continuous function also, yeah, it's continuous.
Yes, we can take G is equal to F.
Great. Done, right? Two. Yeah,
Yes.
two. So yeah, that's the thing that I wanted. So I write the answer because you know the many people will also see the video. Huh? So Z is equal to F. Take Z is equal to F. You can take that because F is also continuous function. And integration of A to B, then F square is equal to 0. F is continuous. That implies F square is continuous. And F square is greater than equal to 0, F square is continuous greater than equal to 0, and the integration of this F square is equal to 0. So F square has to be 0. And F is a real value function, so it has to be 0 as is a real value, right? Function.
Yes.
I wanted to know what are type of the questions are there in the assignment. So, sorry. These questions are like good enough. I mean, no, or it's not easy, right? And it's interesting and also useful, right? Am I correct? I mean, what do you think?
Yes. Yes.
These are kind of simple, but
Interesting questions.
this has a very, like, later you will understand, realize more also. This, it's a kind of this kind of inner product of the product of two functions, which is 0. uh, F times d is 0 for all continuous function z. Then you can generalize maybe few things you can generalize, but this type of results will be useful later also. Then f is equal to 0, that is
Yes.
enough. Huh? It's not a f square is 0. F square you get from that f times z, but otherwise, yeah, f is equal to 0. Means you have f times g that is acting on that function g, and that is 0 implies the function is 0. I mean, this not function is, yeah, function is 0. I'll see also assignment, and before that I'll move to, I'll give another question. It should be useful. Yeah, all the questions I'm telling, I don't know the answer, but I am also doing with you. FG again continuous function, okay? Continuous on AB, and integration a to b f minus g is equal to 0. Then f equal to z, and give counter.
Again, absolute value of F minus G is greater than equal to 0.
Good. So, but yeah, I mean, this is the thing. So, f minus g is absolute value is strictly greater than 0. Uh, okay, why I give, I will tell you. First of all, the result is important. This is something called L1 norm. Okay, so it's greater than 0, and f minus g. So you have to use also few more things, right? F minus g is continuous, right? You understand? This has to be also. This is also true because f and g are continuous. F minus g is continuous, and modulus of that function, continuous function, is the continuous. So it's continuous greater than equal to 0, and if now integration of f minus g is 0, so then integration of sorry, only f minus g, the modulus has to be equal to 0, so f has to be equal to z. That is true. Now give an counter example. Counter example, if not continuous, if fz are not continuous or one of them is not continuous, you were using the continuity property, right? So you have to understand that if not continuous, can you find an example? I mean, it's easy already. I showed something for only one function, so but you have to.
Yes, maybe only at one point f is not equal to j and all other points f is equal to j.
Yeah, I mean, it's you're telling it this, right? F is uh, if equal to z at one point.
F it equals g at all points except one.
At all points, and if not equal to zero at other points, yeah, like some such thing you can just make it. I mean, whatever is this, if you can make it f minus g is equal to like 1 and 0, right? That's what you're telling. X is equal to 0, x not equal to 0. That type of function, even that will work.
Yes.
Choose f and g such that this holds, and then you're done. So that's not a big deal. But yeah, so why I gave them, I don't know. Let me look at the assignment questions. What I feel here that this is whatever other things which might be much more difficult, but it seems like that the assignment
Sorry, there was some
much
network
more.
issue on my
Yeah, sorry, yeah, but yeah, what I'm telling is this assignment seems is very easy. However, we did a much difficult than this. Yeah, I got a question from assignment. I don't know whether it will be difficult. Can you hear me?
yes.
Xt dt is equal to 0. F is continuous. Then number of how many number of such possible function is there? You understand the question, right? F is continuous function and the integration of
What is x?
sorry,
What is x?
x belongs to a real number. Okay, sorry, it's not written. X belongs to real number. Yeah, x belongs to any real number. It is true, huh? Yeah. So maybe I'll write here for all x, and x belongs to real number.
I have got a partial solution.
Mean, tell.
So I substituted for xt.
Yes,
Xt is equal to alpha, say.
yes.
Then x dt is equal to d alpha.
Yeah, let me write. Xt is equal to, sorry, this color has to change now. Xt is equal to alpha.
Yes.
Okay. Then
Then x dt is equal to d alpha.
x dt. Yes. X dt is equal to d alpha.
Assuming x is not 0, dt
If
is equal to
it's
d alpha by x.
true,
Yes. Now I change the integral.
now I've changed the
I
integral.
do the substitution.
Okay, so 0 to 1 f of alpha, right? D alpha over x is equal to
d
0.
alpha by x.
Yes, that
0
is,
to x.
this will change to now. Yes, true. Thanks. 0 to x it will be. Yes, right?
Yes.
That place 0 to x f of alpha d alpha is equal to 0.
Means integral 0 to x f of alpha d alpha is equal to 0.
Okay, what does that then what we will do?
So in the odd function problem, we got the same thing, right?
No,
Something similar.
odd function.
Uh, Means integral 0 to x f of t plus f of minus t dt is 0 for all x in real number.
But here it is different, right? Only f of t, right?
Yes, but maybe we can somehow argue that f of alpha is 0.
F of alpha or f of x you are telling.
Uh, Yes, f the function is 0 function maybe.
Let me check it. F is continuous. I think you were going right, but x when x is not equal to 0, what will happen here? So this function, this you can think like this is gx is equal to 0 to x f alpha d alpha. What do you know about this function g function? G is, what do you know about this?
Differentiable.
Good. D is differentiable because as f is continuous. Hmm. Right? So then g prime also you know then
Yes.
what g prime will be f, right?
F of x.
Yeah.
Yes.
And g prime is equal to f and g is 0. You know g is 0. So f has to be 0.
Yes.
Do you get it? Huh?
Yes.
But f is 0 for for all x belongs to
R
r.
minus 0.
Exactly. So you have to prove that f of 0 is also 0. Then you can say that is only one
Yeah.
function, that is 0 function. But what is f of 0? How do you show that f of 0 is 0? Is it? If so,
X is equal to 0.
0 to 1 f of alpha x, sorry, not alpha, tx, right? Tx was there or something. Tx,
Yes.
right? xt dt was 0 for all x. So even it is 0 for x equal to 0. So f of 0 times t
Yes.
dt is equal to 0. That implies f of 0 is a constant. F of 0 times 0 to 1 dt, which is 1 minus 0, that is equal to 0. That implies f of 0 has to be 0. So the function f is the only, f equal to 0 is the only possibility. It cannot be any more, like it's only 0.
Yes.
Yeah. Okay. So I'll
Yes.
just take some other questions. No, I don't think there are many questions from here, like from the assignment. You have any doubt from the assignment?
I haven't solved it yet
Okay, I think you will find it very easy once after doing all these things. So, like, let's say, like this one, this
yet.
step question was there. One s is equal to 1 by n, such that n is equal to 1 to up to 100, and f from 0, 1 to r, defined as fx is equal to 1, 0 if x belongs to s, otherwise whether this function is integrable.
Yes, it is integrable.
Why?
Maybe I cannot show it rigorously yet
But why? That reason is enough. I don't want that trigger.
because
Yes?
it is one at only discrete number of points.
Yeah, means countable number of points. It is not continuous, right? Means, sorry, discontinuous. Yeah, cannot continue. Means discontinuous. If it's discontinuous, discontinuous on S, which is, I mean, if it's only discontinuous on S, which is countable set. I mean, why I'm writing countable? I could have write finite. Even it is true for countable. If it was S was countable, then also I think it is true. It's countable. As F is continuous, discontinuous on S, which is countable set. I just verify once. I'll just I know I'll just also check. Even is, you understand, right? Even it's not even finite number. Even if it is countable number of set where it is discontinuous, otherwise it's continuous. Then also this holds that F is integrable function.
Yeah.
Let me check once. Mostly it is. I'll just check once. But if you have any textbook, you can check also. I'll just want to check it.
I don't have any textbook, but maybe I saw in some YouTube video that he constructed a countable set and it was not integrable there.
Sorry.
I saw some YouTube video where maybe there was some countable set, but the function was not integrable.
Not integrable.
Okay.
Oh, I see. It might be then. Yeah. Okay, I'll just check. That's why I'm saying I'll check it and I'll let you know. I'll not take much time, just a few, 1 minute, 2 minutes maybe, to check whether this type of results are there. Competition. Good.
Yes, the Dirichlet function. It is 1 at every rational point and 0 at
Yeah, but
irrational point.
that is discontinuous every year, no? That is discontinuous every year.
Yes, but it is
That's not I'm
okay, right?
yeah. I'm telling only at countable number of set. Yeah, I think you can construct that type of function which has uh, mm, I mean, but the result I got, which is telling different thing. If it's a finite number of points, except finite number of points, if it's continuous, then it will be integrable. That is true. Okay, but if f is discontinuous on the set S, which has whose whose set of limit points, set of limit points
No.
is finite. Open set, close set, all these things you knew, right? Oh no, I said something like this only. Just close set means it's not open. The complement is open, right? Like that I told. Okay. So limit point you will not know.
Yes.
Okay, so then leave it all these things because S is finite. That's what I will write then. Eh? That's true. I thought of writing it in a more general way, but I think it's not the time to write. Maybe it is not this. Okay, so which is finite. Okay, so discontinuous only on the finite set. That's why it is integrable. So these type of questions are, I think, there in the assignment. Question from assignment is f from xy to r such that fx is equal to 1 0 if x belongs to q intersection xy, if x belongs to q complement intersection xy. Hmm? What's the value of UPF, or I think is using the notation UFP minus LFP. What will be the value of this? This is the assignment question, okay? So, but yeah, it's going to be okay. You can do it.
Y minus X.
Sorry, y minus x. Yeah. What you got? UFP.
It is summation I goes from 1 to n.
At the end, what you got the value? Y minus x or 0,
Uh, Y minus X.
right? That's what I wanted to know. Okay, so then you are correct. So L of f will be 0. Can very easily verify. I can verify very easily, and that's why it will be the answer. Y minus 6.
But which assignment, from which assignment you are taking this question?
I think this is the assignment which shared with us, So the previous year's assignment or something, maybe I don't know, but yeah, it was shared with us that this thing. So they have shared with us some few now this lecture sessions and all with the previous years, I think. But I don't know whether these are. Sometimes they give this year also same, but I don't know. Hmm? Hopefully, this will be like similar type of, right? I mean, not much difference.
Sorry, I was having some network issue. Can you please repeat?
Yeah, it was like it was shared with us, like the mostly the old course assignment, the last year's assignment, which is shared with us. So I take from there mainly. Most probably, I have not logged in your like the whatever is going on in that uh, tab. They have also previous years things which we can access.
Because this time's assignment is very different.
It's not same. I mean, you cannot do for this.
No, it's not same.
But are they difficult? Like that's what I'm
But
asking.
no, no, they are
What
fair enough.
whatever I am doing like that only, right? That type of, or no, easier than those, something
Yes,
like that.
no problem. It's
Yeah.
medium level.
Can you tell one maybe or something, then so that I can understand what is there, or you will.
The assignment is only on calculating indefinite integrals.
Okay, okay, okay. And like fundamental calculus and all these things. Fundamental theorem calculus, right?
Yes, just no, just integration of dx over. root of 8 plus x square like that.
Sorry, I'll write it. Integration of
Dx over
over
square root of 8 plus x square.
8 plus x square. Yes,
Yes,
and that's all. I mean, that is the we have to find the answer.
yes,
Maybe using UPF, LPF also you can
yes.
do it. I mean, these are easier, right? Than what I was doing. I mean, we have done also same type of things. I mean, you just do it this a function fx, which is 1 over square root of 8 plus x square, and find you will see it is a nice function. You will know in xi to sorry xi minus 1 to xi what is the value of mi and capital Mi, and you just take the summation over small mi times xi minus 1, and you know also about this capital Mi times xi minus 1, and you all do all those business. Yeah, I mean this is much easier. We can People can do it. Yeah, so I think yeah, I mean
I
you have
mean,
to
but I
practice.
doubt that we are supposed to do it using UPF and LPF.
I mean just yeah for the like in your uh, exam and all, so you cannot do like this. So you can just substitute, right? X is equal to what you have to do. X equal to square root 8 times some tan x. I think tan theta. That type of things will do the job or something. Do the job. I think. Right. So yeah, I mean you can do all
Yes,
those.
I think that only we are supposed to do in this.
Yeah. No, okay. If they ask you to verify using all these things, I mean, not in the exam, in NPTEL exam, you will get, but if you get somewhere else, that's what it is. Yeah, but bit better to do using this. It's equal to square root 8 and theta.
Yes, but that was for definite integration, right?
Yeah, okay. This integration value is not is limit is not there. No limit. Okay. Then it has to be like this. Sorry, yes. Okay. So I have many other
Yes.
problems, questions, but which will be much difficult. Let's not do here. I think if you have any other question, you tell me. Otherwise, we can maybe stop after 2 3 minutes.
No question.
Okay.
But
Question. Yes, tell.
this week's content I found a little bit difficult. So, do you have any resources to cover this?
I don't understand. What are you telling?
This week's content I found a little bit difficult.
Oh, I mean, which will be coming, like, I will be teaching. I will be taking tutorial later. That's what you're doing. That one. Next week's. I mean, week 6, right?
No, no, week 5 for the LPF UPF week, Riemann integration week.
Okay. LPF, UPF. Yeah, you can take some standard textbook and I just do it one or two. That is enough. I don't need to do for many things, right? I mean, say small mi times xi minus xi minus.
Is Apostle good?
Sorry?
Apostle calculus, is it good?
No, I mean, for those, you just take some very simple book, I would say, huh? And then do the calculation. Just only to take apostle book.
Okay.
Some simple book you take and just do it. For this UPF, LPF at least I would say, because those are mostly
In
calculated.
real analysis also it will be covered, right?
Real analysis also.
This will be covered, right?
Yeah. Real analysis itself, it will be covered. The real analysis book, yeah. You just find real analysis book, yeah, that will be enough. In real analysis book, you will get it.
Okay.
Simple real analysis book, just like
Yes,
very basic.
because my foundations are also a bit weak.
No, you are okay. You can make it much better, but yeah, you can you read those book, you will understand. Because yeah, these are real analysis book. Yeah, mostly this is not like one. This course name is like calculus of one real variable, but it's up to this we are doing mostly. Not I will say everything, because sequence, series, all these things are not done. But otherwise, the real analysis only first course. So you find the book on real analysis. That will be much better. It's a subset of real analysis.
Okay. But I have started reading Apostle, so is it good?
I mean, I think it is first better to read some other book than episode. I don't know, like if you can take up, then it's okay, good. I never took up it first, so I took a letter just to read. Took some easy book, easy textbook, and did all this thing. But epsilon, delta definition, and all this thing, continuity.
Sorry, I couldn't hear you. Can you repeat?
Yeah, first I did not take. Initially, I did not take that book. Later, I took that book. Took up. It's also not
Okay.
fully covered, but yeah, I mean, there's a few things I did, but mostly I did from some simple book. I mean, very elementary books.
Can you recommend some book?
Yeah, I'll tell you. I don't now remember it. I'll tell you later. You
Okay.
text me, maybe I'll tell you, but because I cannot now. I remember one I remembered, but yeah, that will be maybe very elementary. So I don't want to just tell that.
Okay.
Also, that is not available in the online. Some from here I come, there's some that type of authors. There, like that region's book mostly. Yeah, it's very good,
Yes.
very elementary, that type of. Yeah, I'm talking about just very elementary basic book. That also enough, good enough for all these things. I mean, for the integral, at least integration and all this Riemann integration and all. Otherwise, you can take up
Yes, no,
other
I'm preparing for some exams, so that's why I started reading.
apostole.
Yes.
Yeah, I mean that is good, but I think better first to not read. I think apostole. For like this is my thinking. I don't know. You can people are there who can take up first is apostole. Hmm? So that is not a problem. If you can take up, that is no problem. But this UPF, LPFs are nothing but just a simple things which you do not need to go much detail into the. So for some other thing, it's okay.
Yes.
Like this what we did, this continuity, differences and all these things you can take up, because those are much needed. I mean, we have seen this in the integration itself. We are using continuity idea, also limit, sequence and series. All these things are not done, of course, all this in this course, but that also you can do it, because sequence and series are involved in all this thing. I mean, the integration and all, integration and in the continuity, this sequence and series. Those are also there. You can read those also, and yeah, other things are like limit and continuity. Very important, right? And then all these things
Yes.
will follow. You will see those are not much difficult. And you have this open set, closed set, all these things as one chapter. That also we should read. And then these are, I mean,
Yes.
very. This won't be difficult. Okay.
Yes. No, this is not difficult. This is just new, maybe. That's why. I'm
Exactly,
having
it's not
difficulty
difficult.
to grasp it.
Yeah, it's not difficult. It's a little calculative and nothing else. Other things where if you say difficult, that I can say yeah, okay. But this is not difficult. These are easy. You use some like little techniques, more like a elementary techniques that will come.
Yes.
Yeah. Okay then. I think I'll send you. Just remind me later once. I'll tell you in this week or something. The book name. Otherwise, I don't forget. I forgot now. I have remembered, but
Yes.
I'll see if that I can tell you. Otherwise, even I have the PDF. That PDF I can send you also. Otherwise, you just read. Otherwise, I just check whether I get some other book which is little more involved. Okay. Thank you for your attention.
Yes.
I'll then stop for today.